Thanks for everyone for coming to my talk. This talk is, as Ara said, I was at Dash 2 years ago in the midst of the pandemic, and back then that talk was about our story, our kind of transition to serverless, the company I used to work for. This is more about the lessons that I learned over the last 4 or 5 years in building a culture of observability in an organization. And hopefully you might take some tips and tricks of how to establish a culture of observability at your organization. I'm assuming, because you're at a data conference, you're accepting that observability is a core practice and that you want it to be a bit more widespread in your organization. So, one second. Yeah. So, and then also I might give you a bit of a hint or an insight of why I think democratizing observability is a thing, and why Datadog and all the other vendors I think are moving towards that direction. But first I want to give you a story about observability in biological systems, and in particular in human cells. I was talking to my partner about observability in software systems, as you do. She heard me a lot in calls, so I had to explain a bit what observability is. So I asked her, how do you in your field observe biological systems, your human cell? How do you find the Wally in the trillions of different components in the cell that interact with each other all the time? A very, very complex system. So she explained to me that you can take various laborious and time-consuming biochemical and biophysical techniques to extract, to isolate the little Wally, the little component that you want to study. And if you're lucky, after a few iterations, and actually after a few years, you might find your Wally, you might find your isolated protein that you can actually study. And this is great, but it takes a lot of time, the lead time is high, and it doesn't guarantee success either. So the second way that's suggested to talk to me about was this process of tagging. So they re-engineer the DNA of the cell so that they can color code different types of components within the human cell. So they use blue, red, green. And that way, with that very elegant and simple technique, once they subject the cell with various different experiments, they can actually observe what's happening in the cell in the context of the human cell, not in isolation. And that's a massive win, as we know from software systems as well. So I found this fascinating, so I thought I'd share that as a first story for this talk. By the way, my partner is a postdoctoral research fellow in synthetic biology, so she knows this stuff, so that's why I was asking her. But I'm Toli. Ara's made the introductions already, but I'm half Greek, half British. I work for Flipdish, which is a company that works in restaurant tech. But previously I worked for a company called Cinch, which is an automotive car seller online, and that's where I got most of my insights about observability. To be honest, when I first started out, before I started out in software, I would never have asked my partner these questions. How does this cell work? How does the software systems work? I really, really didn't care. I studied maths and mathematical physics, less than mathematical physics, but more on the pure maths. So I really didn't care about any of these concepts. But then I got hired as a software engineer in a company that was building algorithms to solve the traveling salesman's problem for large-scale problems. So I couldn't really tell that I was a developer for about 2 or 3 years. I felt as a real imposter. But then I started getting a bit more confident, and I thought I could do this really easy. I got another job. I worked for an energy company. They had actual customers rather than the B2B that the previous company had. And within the first 1 or 2 releases, I broke production. And I mean, I don't know, just a show of hands if you broke production ever in your life. Yeah, very good. So it's a common thing. But it was very stressful. And that's when I started reading up concepts like DevOps and kind of catching on those movements that I'd missed out on. That's around 2017. But I also came across this concept called observability. And as Ara was saying earlier, I became very passionate about it. And the reason was it started unlocking potential to handle production systems a lot better than I was used to. So you might wonder, why am I here? So it's all good, but what is my main point? So I've got this thesis that the more observable our systems, the more democratized our understanding of our software systems across the organization. So this talk is evidently about observability. So before I move on, I want to give a quick definition, or at least how I think of observability. And this is a definition from the Observability Engineering book by charity majors Luis von Jones and George Miranda, where they state, amongst other things, if you can understand any novel state without needing to ship new code, you have observability. So it's not about you have an incident, that incident that I had in the energy company, and then we add logs after the incident. You can do that, but with observability, you have that capability already. That's the big difference. And if we break it down, observability is not a verb. It's not something that you can do. It's a property or characteristic of the system. You can explain any bizarre or novel state, but critically, without shipping new code, but without predicting any state. So you don't need to, like we do with testing, predict what might happen. You do it in a way that it's more systematic and methodical, and you can answer any questions on the other side. The second point I want to make before I kind of move on is, it's not another fad. It's not something, I don't know, there are, say, LLMs, for example, they still have to prove themselves, or blockchain. Observability, in my opinion, is here to stay, and I want to give you 3 arguments of why I think that. The first one is DORA. So again, quick show of hands. Have you heard of DORA and know what DORA is? Great, perfect. I'll give a quick definition. So DORA has been a long, years-long, almost decade-long research program on DevOps maturity. So they send out assessments every year to thousands and thousands of people and organizations, and they assess the maturity of all the companies in DevOps maturity. And in DevOps, sorry. And Accelerate was a particularly amazing moment in the DevOps movement, because it took DevOps from a hip movement to an actual mainstream, we should all do DevOps. Because they proved that, I think I've got this in the next slide, using these 4 metrics, you can measure DevOps maturity. So how many times you deploy to production, what's your lead time to production, how many times does that deployment to production fail as a percentage, and how long does it take you to restore that service? If you're doing well in all these metrics, you're doing well in DevOps, but the critical thing that Accelerate proved, that there was a predictor relationship between elite DevOps maturity and company success. So you make money by being good at DevOps. So that was pretty powerful, and everyone's really excited. But then in later assessments, later years from 2018 onwards, they started seeing a 5th metric emerging in reliability. And you might be wondering, why am I talking about DevOps when I'm meant to be talking about observability? This is when observability comes in, because they're starting to find that it's not enough to deliver well, you also need to operate reliably too. And a lot of things go into reliability, but observability is one of them. The second point I want to make about observability is that increasingly teams are building, shipping, and supporting their own software. And although we've got really good at building and shipping, we've got, it's really hard to support your own software, especially if you're a developer, especially if you're a cross-functional team. So observability is a key capability that can help you do this. And the third thing, which might be obvious, but we often overlook this, is that systems are complex. Probably for good reasons. We have distributed systems, we have microservices, but they are complex, and they're hard to fit in one person's head or a team's head. This is an actual service diagram of all the services at Cinch, where I used to work. And it's really, really hard to find Wally on the bottom left there, because there's a lot of things going on here, and it's quite complex. So having good observability will help you. So hopefully I've persuaded you that observability is something that will just increase as a capability across all organizations. There's various white papers out there that indicate the same. But the main point I want to make is how you can establish a culture of observability. So it's sort of easy because you're at Datadog already, so that's the first step. But there's 3 steps. You choose your observability tool. You might choose Datadog. You enable your telemetry data, as we saw in the keynote earlier. It's a lot easier to enable all the telemetry data, enable all the traces. and then auto-generate the dashboard, which Datadog does for you really well, and then you're done. So I'm happy that a few people laughed, because the key takeaway, if you take anything out of here, is that you can't plug and play an observability tool. You can't buy an observability tool and just give it to people. You're wasting money, and I might say this a few times, it is expensive. So it's not really about those three things. But what occurred to me after a while of working with teams and people and trying to persuade them that they should be considering observability is that observability is the testability of the 2020s, but in a way better. Because what I mean by that is tests tell you what's broken, whereas observability tells you what's happened. So what's more important, what's happened or what's broken? And critically, the broken bit is you know about it in the isolated lab testing on your laptop, on non-prod environments, not on the kind of widespread field testing that we do observability in the actual production systems. Another way of looking at it is there's this really, really good book called Thinking in Promises, and it's all about how you look at software systems as agents that make promises and how the other agents interpret those promises. So if we ask ourselves, what promise are we keeping with testing? Well, a promise that will change the software and it won't get worse. If anything, it'll get better. That's something that we're trying to keep with tests. With observability, we're saying that I promise you will have a service and you can rely on me. If I make a change, I promise that your service will get better and I will know if it doesn't. Again, it's probably more akin to reliability here, but observability is the key to knowing whether you have reliable systems. And this is a nice diagram. I'm sorry to kind of use your hands again, but a big show of hands if you've seen this type of diagram before, the unknowns and yeah. So this is very popular in the observability space. There's the y-axis being level of awareness, the x-axis being level of understanding, and testability in a way enables things that we are aware of and understand, whereas observability unlocks this potential of things that we're not aware of and don't understand. So we can be very curious and understand and figure out things that we never ever expected. So I hope I've kind of set the scene a bit. And now I'd like to say, well, you know, what do I do? Well, the first thing to understand is that what we're doing with observability is we're creating and curating our telemetry data to enable observability. Again, it's not just plug and play. We need to think a bit more consciously about what type of telemetry data we're creating. So where do I start? So I kind of said that there's no three things, but if I look back, there are actually three things that I figured out that are the most useful. So yeah, you do have to pick an observability tool, but critically, you have to let everyone have it. You need to instrument your code, and you need to support and enable learning, the third one being the most important. But if we start with the picking observability tool quite quickly. So the first question, that you might want to ask is, well, how do I choose? How do I choose an observability tool? And I know we're at a Datadog conference, but just to give you some heuristics in case you want to look around. The first thing is, can everyone use a service with no extra cost? If you want to enable everyone in the organization to use this tool, they can't have barriers for entry. An example for barrier for entry is GitHub. GitHub is seat-based, and a lot of people can't get access, like non-techies, because it costs more. So that creates silos, unintended silos. I don't know of any observability vendor that has a seat-based rather than like ingress of data billing model, but you have to bear that in mind. Second thing is the developers are going to use this tool. You want them to use this tool, so you want the observability vendor to have excellent DevX tooling. And that's really important. Your SDKs, your traces, that kind of stuff. It needs to be really, really good. And you need to enjoy when you use them. Third heuristic, is how far can you get without checking production? And what I mean by this is, I see the cloud providers, for example, Azure, AWS, Google Cloud, as the operating platform. I see the observability vendors as your understanding platform. So you have your understanding platform, you have your operating platform. You shouldn't have to log into your operating platform for various reasons, for security reasons, for avoiding ClickOps, all these things, but you should be able to understand what your software systems are doing through your observability provider. And the question is, does the one you're going to choose enable that, or do you have to then switch between cloud providers and observability providers? And finally, it's probably the most, the most important one for a lot of people, especially if you're a decision maker in your organization, is can you manage billing effectively? Traditionally, from my experience, the billing is not transparent, it's not easy to manage. There's various mechanisms that you can use, but it's not as easy. You need to learn a lot. It's a steep learning curve. So that's something that you need to look at when you're looking at observability vendors. Then I just put a few examples. I've classed them as established, so your Datadog or your Dynatrace, that type of organizations. Your startups, which is kind of newer generation observability vendors like Honeycomb, or more specific observability vendors that, in my case, I chose serverless because in my previous organization we're entirely serverless, but you'll find these niche observability vendors that are a bit more specific. So Lumigo is an example for that. So that's it with your picking your observability tool. The second thing that's important is instrumenting your code. And I don't know, has anyone here before heard about instrumenting code? Put your hand up. Yeah, so quite a few, that's good. Good. So I just added some pseudocode here of order placed. So this function responds to an order event and has some business logic, but the important bit is it has some tags, order ID, user ID, order placed. Because instrumentation is the practice of systematically configuring your code base to emit telemetry data. Because then it provides insights into how your code is exercised by data in production. That's my definition of instrumentation. But once you instrument your code, you get the ability to diagnose problems, you get the ability to learn how your software is used, you get the ability to get ideas, potentially, from how your software is used to improve it. So learning how to instrument is important. So this is your developers in your organization. They need to learn how to instrument like they know how to write tests. Because, and also a lot of the developers know how to do logs. But logs in this kind of diagram, again, are probably more akin to the known knowns. So you kind of know it's happening. You write the log, you send it to Datadog. Whereas with tags, you enable these unknown unknowns. Here's an example. So with a log, you can say an order was placed with order ID XYZ. But a better way to do it is to add these tags that you saw in the earlier example. So order ID, user ID, order placed. You're building a data set of useful attributes that you can then query, rather than a list of free text, even if that's a structured log. And the way I tend to explain is you have to think of every input, output, or parameter in your code as an opportunity to learn. Your code is going to be in production, it's going to be exercised by users. What can you learn at any line of code? So these are your opportunities here, because that's where your users are. That's what happened. This is not in isolation from the people who use your software. But you can ask any question. This is why it's so powerful. So you can say select star from order event, where user ID equals X, if that's what you want to ask. Or you can say select star from order event, where order placed is true, and get those answers. But you don't need to know ahead of time what questions you want to ask. You don't need to go and look at the code and see what the log is and where that log is, and then correlate the two. So in summary, on the instrumentation, I would say that you have to do three things. Anytime as a developer, you need to be thinking about writing code, writing your tests, and instrumenting your code. And I always put this next slide in because I'm afraid of the TDD aficionado. So like you might write the test first, then write the code, and then instrument. That's fine. Or you can do any permutation of this as long as you do these three things as a standard practice. So that gets out of the way the observability tool choice and giving everyone access to it, instrumenting the code, and the most important thing, my biggest takeaway, is supporting and enable learning, because you won't be able to really have a high observability maturity without enabling people to learn. I saw this very interesting quote by Adrian Cockcroft, and I actually heard it in the Hack in the Org podcast by Charles Humble. He said that you can construct the behavior of a system from its externally visible components. That's what you're doing with telemetry data. So you have this black box. It's giving all this information. You start predicting the behavior of the system, and that's what observability is. But the problem is, how can teams make sense of all this data? How can teams make sense of all this information? And that's why you need to support, learn, and actually practice as well. That's a really critical step. So step 0 almost is to add observability to your golden path, your paved road, the way you do engineering in your organization. What I really mean here is that you have your hosting paradigm, in our case it was serverless, your event-driven, your kind of architecture paradigm, in our case event-driven, or trunk-based pairing, mobbing, TDD, all this stuff. Observability needs to be there alongside all those guys. The second thing that I think is very, very important, you need to plant enablers into teams. You can't sit from far away and say, here's a tool, use it. You have to think a bit more consciously about your org design. In our case, we used automation engineers who were basically software engineers who just had a knack for learning infrastructure as code, CI/CD, observability, and they would sit there and say to the team, guys, how are we going to know if this works in production? And then if they said, well, we won't know, then they started introducing techniques and practices of how they can achieve this. Principal engineers sit outside the core team and support in similar ways. And I'd like to call out the supporters, the service delivery managers. That's what they were at Cinch. But these people are very good at kind of building workshops. It's the more social aspect of things. They can build workshops like service readiness, like what's alarming you, which helped teams understand their P1s and their P2s given the service they were supporting. Really, really important. Third thing that I thought that was really, really important is a community of practice. Peer-to-peer learning is the most powerful thing I've come across in organizations. Often we think about structural training or just self-learning on your own as the best thing, but I've not seen anything more powerful or actually effective than community of practice. We had a community of interest in observability at Cinch, and that actually created some workshops for others, but they created these collaboratively, and interestingly, this was with Datadog notebooks. You can't do any of this without psychological safety, so this is Westrum's 3-culture model. You need to be on the far right in the generative column if you want people to learn. Instant reviews, incidents are a fact of life. They'll happen, so you need to make sure that you're learning from them. That's the first thing you should be thinking about once an incident has been remediated. And remember when I mentioned practice, we ran regular chaos days in teams, but even across teams, and these were really practice days where an incident would happen and then the team would learn how to respond to that incident. They would learn how to improve their observability. And working groups also started to emerge to create good practices around instrumentation, code instrumentation, and general observability practices. And as a result, we got this Cinch Brew example application, which had documentation and code that demonstrated good practices. And that's it. Those are the 3 pointers I have to build a culture of observability. And the next thing to think about is what can possibly go wrong. And these are signs that I see in organizations, and hopefully I might see some smiles here, or you might be, this might relate a bit. So you've got a company where one person knows everything about observability. On the flip side, nobody understands the dashboards. You have loads of dashboards, but no one really looks at them, no one understands them. The third one that I see often, and this is quite an interesting one, is the overuse of infrastructure level metrics. We're so used to monitoring 400s and 500s, which is very effective, but we want to think about more business-related telemetry data, so your orders, the things that are important to your business. And finally, knowing the what but not the why. So a lot of organizations have a lot of alarms coming in, telling them that something's wrong, but they can't quickly understand what's actually wrong. But then on the flip side, when do you know that you've made it? So on the team level, observability is a team responsibility, and that actually does happen. On the individual, observability practices become core skill. They started putting them on CVs and on LinkedIn. And on the org level, all teams practice observability-driven development. And it's akin to testing. So you might wonder, well, why does all this matter? Because, as I mentioned earlier, observability is expensive. Just an interesting nugget of information, our Datadog bill was more expensive than our AWS bill. because we're entirely serverless, so that kind of makes sense, but it is expensive. But on the flip side, instants are rare. We did have instants, but we didn't have that many. And also mean time to recovery is not an issue. I kind of tried to look for a stat for mean time to recovery, but it didn't really matter because we recovered pretty quickly without much impact. Most of our teams were elite in terms of DORA because of observability. Interestingly, when Datadog had a serious incident a few months ago, we stopped doing deployments because we can't see anything. We can't see how our production systems are doing, so we're not risking anything. So that's how important it was for us. And finally, all the teams had their eyes on production systems. They were testing in production, if you like, if you want to use that phrase. And that is really, really powerful. You started getting dashboards like this, the order squad's motherboard. This is the orders team and the engineering, product engineering team. They started asking questions, are orders looking healthy? Then, is part exchange service healthy? What changes have we released? Do we have any instance? Are we seeing errors? And only towards the end, you get, are my APIs healthy? So more infrastructure level questions. At the start, you have all the business level questions. So I started saying that observability is democratized. So I started with this thesis. The more observable our systems, the more democratized our understanding of our software systems across the organization. One thing that I started noticing, and speaking to Ara about this earlier, was observability is starting to eat through the worlds of business analytics and data intelligence, or at least it's blurring the lines. And when I was building this talk, I came across this workshop that was built by BAs for BAs to learn about observability, which is surprising to me. I didn't expect them to be interested in observability. And actually, it finished like this. The observability is not just for technical people. Because understanding of the software is only as good as your telemetry data. That's the thing you'll find out quite quickly. Traditionally, what would happen, you would have your software engineers being your curators and your business analysts being your consumers, with your business analyst saying, can you install this SDK? The software engineers would action it, and then the business analysts would be the only people who would analyze the data. But nowadays, what's happening is that they're merging a bit more. So software engineers and business analysts are curators and consumers together, just like we did with DevOps. Devs have taken ownership of the quality of the telemetry data, and then as a nice result, you get lovely widgets like this, where the payments team at Cinch was actively monitoring single card usage versus multiple card usage. It's an interesting thing, by the way, just a quick aside, that buying a car is an expensive payment, so it takes, you can't typically use a single card because of card limits. So we had the ability of paying with multiple cards, so they knew at any point in time what percentage of users is using multiple cards versus single card. The other one that was interesting that I noticed is that they had a funnel conversion in Datadog for finding a vehicle all the way to checkout. And that's there's a very analytics view of the data. It's not just infrastructure here. And also kind of, they always knew what the top model and make searches are. And this is where the users are. And that's what I'm finding really insightful, is that a lot of the non-devs, the non-techies are actually using tools like Datadog to understand how the users, how the people are using the software. So wrapping up, I spent a few years, and a few other people were asking this question repetitively: how do you know your code is working in production? And as a result, we had 20 plus teams practicing observability like it was a standard practice. I kind of joke a bit that observability is better than testability. I think it's more, they're complementary, but if you had to choose one or the other, which one would prefer, production systems working or your non-production systems working? And then these are the three things I suggest to use as a compass of how to start building a culture of observability. When I started out, there was no really good literature in observability engineering. There is since. So I'd suggest reading Observability Engineering if you're interested. If you're not into books, Charity Major is a great person to read her blog posts or her tweets. If you're not into reading at all, listening to a podcast is a good way of learning about observability. But if you do anything, I'd say take observability seriously, but make it work for your use case. I know I've just given you three prescriptive ways of doing it, but this is just a a tip. Because if you do, you will amplify and democratize the understanding of the behavior of your software system. And in a way, the way I see it now is that the lack of observability is our collective tech debt, like testing was a long time ago, and we're now improving it. And that's it. Thank you very much.
That was fantastic. This is not the first time that I listened to this, because I sat with Toli on the dry runs, and I found his talk super inspiring. So thanks for sharing. So we have one question on Slido. So I'm going to ask this first, in case it came from live stream, and then if anyone wants to ask questions, just raise your hand, and I'll pass the mic. The question is: it's great when an organization has an observability champion, like yourself, but when do you think we will start seeing companies hiring for observability engineers, specifically?
Yeah,
or whether it makes sense?
Yeah, that's a really good question. I was quite lucky that the engineering directors wanted observability. They came to me and said, one Christmas, they said, go and learn everything you can about observability and let's make it happen. On the flip side, that's sort of why I'm here. I'm trying to, I don't know if we have any engineering directors in the room, I'm trying to persuade everyone that the sooner you start your journey on observability, the better for your organization. To be honest, from where I worked at Cinch, we're starting to see people putting Datadog and tracing and all these things and instrumentation on their CVs, and people are starting to take notice, but I think it's very, very slow, if I'm completely honest. And I don't know if it's worth having an observability engineer. I think you would probably call them SREs, but I think my key lesson here is that we did it as part of the team. We didn't have a separate dev and ops. So they were more advocates and enablers rather than doers. So I think that would be the separation. The more we get ops creating the alerts and creating the telemetry data, then the devs will never learn how to be curious and how to observe the data.
Good. We have another question. Well, actually 2 questions, which are the same one. People are, they found so many great details in your slides, and they were wondering if you're going to publish them anywhere.
Yeah, absolutely. I'll publish them on my website, toli.io, and on GitHub. I'll share I'm sure we can share them later. Yeah.
Cool. Any questions from the, yes? Yeah. Wait. Let me wait for the mic for the recording and the live audience and the live stream audience.
So I consumed a lot of Charity Majors' content, and she says that having essentially high cardinality data is the essence of observability. Do you have any best practices for managing all of that high cardinality data within Datadog, to relate it back to Datadog?
Yeah, that's an excellent question. So Charity Majors is probably the person who coined the term observability, well, at least borrowed it from mechanical engineering, I think. I think my biggest lesson, to be honest, is that you can't take what Charity Majors and Honeycomb are doing and apply them to a different observability vendor, because they're built differently. So that's number one. With Datadog, I would say that it's a bit different to add custom tags on your spans and do tracing. But I'd say that if you can have traces and custom tags and then generate metrics off your tags, I think that would be my go-to. But at the end of the day, you have to look at your observability vendor and see what they give you, because what Datadog does really well is connecting traces, metrics, and logs. So if you listen to Charity Majors, she'll say, we don't need any of these, we just need events. And that works in Honeycomb, but it doesn't work in Datadog. So you have to use what you have in front of you, and it's really powerful to be able to link the three traces. But the thing, I think it goes back to what Datadog says, use unified tagging, service tagging. So always add a service, always add a version, and always add an env, and then a lot of things fall into place after that.
Cool. Well, one second. Yes, I'll go back to you. I'll read one of the questions on the slide, and then you go next. So the next question is there more value in having observability as part of a golden path or a separate golden path? Which I'm not sure I understand the question.
It depends who implements that golden path. I think the golden path that I showed earlier was the product engineering teams. And the same teams that built the software, they shipped it, they also supported it. If you have a separate ops department, then yeah, you probably want a different golden path. I think that's what the question meant. But if you're in the room, please put your hand up and clarify.
Okay, hey, great presentation. So you gave a presentation a year or two or whatever. So think ahead a year to 2 years from now into another Dash presentation you're going to give. What would you be talking about observability? What would you be adding to it? AI would probably be one, but what?
I'm going to be very cautious to kind of fall into the hype of LLMs. I think one thing that I found interesting in the releases today was the Bits AI. So if we can use generative AI to get more people to look at telemetry data and understand them, so kind of bridge that gap between, oh, I've got this UI with loads of data, how do I make sense of it, to actually make sense of it, that will be really powerful. So hopefully it'd be something along those lines. But the other bit is, I'd say we're still very early stages. So the company I've just joined, they have a lot, so Flipdish are really good at observability, but they have their own unique challenges, which I'd probably say that my next talk would be about that, because every company is different. Yeah, but good question.
And we have time only for one last question. We got one in Slido. So, a classical question about the tension between product and engineering. Most times there is an inclination to ship code fast. As a result, observability and instrumentation end up taking a hit. Any tips to get product on board?
Yeah, I do actually. So one of the things that I left out from the talk was we had teams where product owners were looking at dashboards. And actually, although I don't like logs, because as charts majors probably be against logs as well, but logs are very good for non-techies to look at a dashboard and understand what's going. So they would be the first line of support on things. They would look at the dashboard to understand what's going. They would look at the dashboard when they wanted to understand every morning how the health of the business transactions are. So I'd say my tip would be get product people involved in the value of observability, and then everything will fall into place, he says, hopefully.
Okay, thank you very much again, Toli. Great talk.
Thank you.